Okay, we are asked to find the horizontal and vertical asymptotes of f of x. Now, there's lots of different ways we can do this. We've explored some algebraic ways, but let's talk about putting it into our graphing calculator. So what we're going to do is we're going to start by simply graphing this equation. So I have 6 divided by, and I'm going to do x minus 3. And notice I'm using parentheses here so that it's not going to do 6 divided by x minus 3. Because that would be a different function. Obviously, I want to make sure it knows the entire things in the bottom. So I always use parentheses to ensure that happens. And then I'm going to graph it. You can see right here I have my asymptote, and I can see there's my horizontal asymptote because I can see where they're approaching. So I can look at these. So when I look at this, I can see that I have here, and I'm going to use my trace button to look at this, I can see that as I come over here, and then I want to jump to the other side. Yeah. I can see that this is 1, 2, I'm at 3 here, and as I look at this, as I go down my x's, here coming back here, I should be able to see, and obviously if you make this out, I'm going to change my window. I'm going to expand out my window a little bit better so I can see it. I'm going to do 30 by 30. Oh, that's not the way I wanted to go. Let's go try my window again. Oh, because I did x max. And then I want to do this too, negative 30. And there, so then as I do the trace, and probably I want to make my thing better, I can more easily see where that, oh, it just disappeared and went, and that's between, all of a sudden looking at my x's, I can see that it skipped 3. Obviously this isn't as precise when you do it algebraically, but it's going to give you the same idea. And then my horizontal asymptote, again, I can see going right there along the x-axis, so that's at 0. But I could use the trace, or I could use, one of the other buttons to follow along to find it. So when I come in here, my horizontal asymptote is the line y equals 0, the horizontal axis, and then the vertical asymptote is x equals 3. And then I can pick out my graph, and again, coming back here, I can see that, okay, I've got the bottom one and the top one, so I know what it's going to look like. So I know, looking at this, that it has to be either B or D. We can see looking at that, then I have to find the one that goes with it. So I usually like to expand them so I can look at them a little bit better. And I can see here 2, 4, 6, 8, 10. So that's 2. That's it. 3. What's the difference between this? And let's come look at this one. So that one's at 3. That one's at 2, 4. Yep, this one's too far out. So this one over here is the one that's at 3. And you'll notice this little button, expand it. I always do that because I can't look at these and tell which one's at the right one. I knew it was one of them. Which one it was, I had to look a little bit more closely. So hopefully you can see that as you're doing these, obviously use the limits, use the methods we're doing by hand, but it's also nice to be able to see the graph and see what's happening and seeing how those asymptotes and the limit, you can see how the limit actually thinks here. It's never going to actually get there. That's the concept of a limit done out for you on the graph.